Okay, what we've been doing is working in the notebook file for this week and doing two problems from our homework from Monday night. And those two problems were the solubility assignment, and the first problem that we did was right here, and this problem was doing chemical 1 with chemical 2, and then the next one down was doing chemical 1 with chemical 3. And the place where you're going to find that kind of information is on your lab sheet. And that's where those numbers refer to. This is chemical 1, and when we mix it with chemical 2, we're doing lead 2 nitrate with iron 3 chloride. Here, if we're doing 1 with 3, we're doing the lead nitrate with the aluminum sulfate. And this is lead 2 nitrate. Okay, so that's where that stuff comes from. Now the job is to figure out who's the precipitate. And for that, you have to have a solubility chart in this form or some other form. And this is something that was originally worked out by Mrs. Taylorson, and I copied and modified, and you know, you always got to improve on things, so I'm one of those. Now, when you're trying to figure these guys out, the first place you start is with soluble stuff. These guys are soluble with just about everything. And so you look and see on your things that you're trying to figure out, do we have any of those guys on the list? And so if you're looking at that list right now, which you all should be doing, we're going to look for lead. And now when we look for lead, and why am I looking for lead? Because lead was right up here in our first problem. And I want to see if the lead over here, the lead chloride, is going to be soluble or insoluble. In other words, is it going to dissolve in water, or will it not dissolve in water? If it doesn't dissolve in water, we call it a precipitate. So we're looking for lead on our list, and we don't see lead on this list anywhere. So now we're going to go to our negative dudes, and we're going to see if we can find on the right side of this equation, we've got lead 2 chloride. So let's look for chloride. And I don't see chloride anywhere here. Aha! Chloride won't ionize with these two, with any of these guys. So, ooh, look, lead and chloride won't ionize, insoluble. That means it's going to form a precipitate. And so what we do is we go back to our formula and we write a subscript. Oops. Let's put this guy back where he was and get this over to pen. And now this guy is going to get an S. That means he's a solid. Now he doesn't look like a solid. He's not a rock. But when you mix this stuff up, the water's going to get cloudy, and that cloudiness is going to be the lead chloride. And that is a solid in water. If it sits there long enough, it will all settle to the bottom, and then you don't have it anymore. Now let's see if that iron nitrate is going to be a solid also, or whether it's just going to be one of those guys that's going to be sitting around. And so let's go ahead and look at him on the chart. And now, iron, is he on the list here? No. Okay, who's iron with? Come on, who's he with? Yeah, he's with nitrate. All right, so we're looking at this guy right here. All right, so iron nitrate. So we got to look for nitrate. These guys always ionize. Is it on that list? Yeah. Yeah, it is. There we go. That baby's not going to form any precipitates, ever. Okay, nitrates are never soluble. Okay, so these are, I'm sorry, nitrates are always soluble. They never form precipitates. All right, so we've solved the first one. Now we go to the second one. We are looking for lead nitrate. We knew already that lead is not on this first list. Okay, and so we're going to lead sulfate now, and that's over here. And let's find lead sulfate, see if lead sulfate, is sulfate on the insoluble stuff with lead? He's not in that list, is he? Is sulfate here? Okay, is there lead in the list next to it? Aha, there's lead. Okay, so lead sulfate, that baby is insoluble. That means he's going to form junk in the water, and that means the water will turn cloudy, and that also means that here in the equation we're going to write an S, and that identifies it as the precipitate, because it is going to form a solid in water, and the water will look cloudy, and it will float down to the bottom, or it will settle down to the bottom, and then we're not going to see it anymore. Well, we won't see it in the water. It's going to be on the bottom of the beaker if we're doing a beaker full of it. All right, now let's check out our aluminum nitrate. The aluminum nitrate is right here, and let's check him out and see if we see aluminum on our first list. Is aluminum there? No, not there. Okay, so let's start looking for nitrate. Ah, we found out about nitrate in that last one, didn't we? Nitrate is not going to form a precipitate. And so this is how you're going to do your do now. It's exactly how you're going to do your do now. You're going to mix the two reactants together, like I did in this slide, and you're going to get your products, and then you're going to check them out on your solubility list and find out whether they're soluble or insoluble. Any questions? Okay, let's go ahead. Okay, we put a new problem up. This is 1 with 4, and let's take a look and see how we're going to get this guy balanced. First of all, we're mixing lead on the right side of this equation with chlorine, our chloride ion, and that's going to form the lead chloride. And then the hydrogen from the hydrochloric acid that's on the left side is going to form nitric acid on the right side, HNO3. And this will go forward if one of these is going to be a precipitate or form a gas. So we're going to look at lead on our chart. I think we already found this one out, didn't we? Didn't we find this out already? Lead isn't on this list. Lead with chloride. Aha, here's lead, here's chloride. Insoluble, won't ionize. That means it forms a precipitate. And look at this box down here. This will also help you. We didn't look at that earlier. Ionize means it dissolves, which means it's soluble, and there is no precipitate. If it won't ionize, that means it won't dissolve in the water, which means it's going to go to the bottom, right? And so if it's not soluble, a precipitate will form. Got to be careful about soluble and not soluble. Make sure you don't mix those up with precipitate, because they're inverse. If it's soluble, it won't form a precipitate. If it's not soluble, it will form a precipitate. Okay? So I'm trying to keep these out here and just use these terms: insoluble across here, soluble across here, and soluble down here in the bases. All of these bases are soluble in water. Okay? So that should do it for you, huh?